Hello, and welcome to this presentation on the precedent rules and the application of the mnemonic BODMAS. This presentation builds on two previous presentations, one associated with the precedent rules applied to numerical calculations and one associated with the precedent rules applied to fraction calculations. But within this work, we're going to consider algebraic expressions such as that shown here on the slide. It is assumed you've seen the previous presentations on the precedent rules, as that work underpins what we're going to review here. So precedent rules, as we've said before, the order of precedence of an arithmetic or an algebraic expression is given by the mnemonic BODMAS, where B indicates the highest precedent being brackets, O is the next precedent being operations, D is the next precedent using division, M is the next precedent multiplication, A, next precedent is addition, and the least precedent in the BODMAS framework is subtraction. So what the BODMAS mnemonic is trying to explain is that if we have brackets in our calculation, we must consider them first of all. If we have operations such as indices, trig functions, etc., we consider them next. Division next, multiplication, addition, and finally subtraction. However, as I've mentioned in the previous presentations, in fact multiplication and division actually have the same precedent as does subtraction and addition. So I prefer to write BODMAS in terms of the pyramid structure shown on the right hand side here. So essentially within the calculations we're going to take the first priority will be to consider brackets and try to evaluate them. The second priority will be the operations, the indices, etc. The third priority on our calculations will be division or multiplication. And the fourth priority will be addition or subtraction. So I prefer to think of BODMAS in the pyramid structure because sometimes it's preferable to multiply before divide or subtract before add. Let's briefly look at some terminology associated with algebraic expressions. We're given the algebraic expression 3x minus 5 plus 10. So, considering the terminology associated with this expression, the x is termed the variable. We often use x for the unknown in an expression or an equation, but we can use other symbols as well, such as y or t, or Greek symbols such as alpha and theta. The number associated with the x is termed the coefficient of x. So in this case the coefficient of x is 3. We have 3 multiplied by x in. The numbers 5 and 10 in the expression are defined as constants. They are pure numbers. And finally the minus and the plus in our expression are termed operators. Just notice for reference that the minus could be expressed also as subtract or take away, and the plus could be expressed as add. These terms are essentially interchangeable for us as technician engineers. So that's just some basic terminology we sometimes encounter when we're simplifying algebraic expressions or solving algebraic equations. I'm just going to consider one example of a pure numerical calculation just to recap the BODMAS process. So example 1a, we're asked to evaluate the following arithmetic expression. So given the expression 10 multiplied by, in brackets, 8 plus 4, or divided by 2, and then add 12, we have to evaluate this using our precedent rules. Just for reference, if there's no symbol between the numbers or between the number and the bracket, we assume multiplication, and sometimes large dots are used in mathematics to indicate multiplication. First of all, we consider brackets. Do we have any brackets? And yes, we do. So we have to evaluate the brackets first of all, where possible. So on the next line, I would have 10 multiplied by 8 plus 4 is 12. So multiplied by 12, don't need the bracket now. That's all divided by 2, and then we're adding 12 into the sum. So reviewing the calculation now, the precedent lies here with the multiplication or the division. So I think I'll actually do the multiplication first here, just to show we can do that first if we want to. So 10 multiplied by 12 is 120, and that's still divided by 2, and we have to add 12 to that. Now the precedent resides here with the division. So now in taking the division, 120 divided by 2 will be 60, and we add 12 to that. And finally we consider addition or subtraction. We've got addition here, so 60 added to 12 is 72. That's our final answer. So that's applying BODMAS to a numerical calculation. The essence of this presentation though is to apply BODMAS to algebraic expressions, and that's what we'll be doing on the following slides. Example 2a, we're asked to simplify the following algebraic expression. So we're given 14x divided by, in brackets, 5x plus 2x, and we're subtracting from that 6x. I'll rewrite the equation on 2 lines just for clarity. So basically we've got 14x, and that's all divided by, in this case, in brackets, I've got 5x plus my 2x, and we're subtracting from that 6x. So applying BODMAS here, the precedent lies with the bottom line here, the bracket is showing here, so I'm going to solve that first of all. So now we have 14x in the numerator still, but it's divided by 7x. In other words, the 5x added 2x is 7x, and we're subtracting 6x from that. For reference, it can be useful to put the numerators and denominator of a fraction in brackets because it helps with perceiving the order of precedence. Looking at the next sum, the precedent lies here with the division. So on my next line, I've got 14x divided by 7x, where the x's cancel here to give me 1 and 1, dividing top and bottom by x in other words, and the 14 divided by 7 is 2. So I get 2 minus 6x. So we simplified our expression as best we can. We've got one constant, the 2, and we've got the x term, the negative 6x. We could factorise from here if we wanted to, because 2 is common to both terms. So we could take 2 outside of a bracket, and inside we would get 1 minus 3x. So that's the final factorised form shown here, but don't worry too much if you don't follow that for now. As long as you can follow the process down to this line, that will be fine. You will find within this presentation that the use of factorisation and even the use of indices will crop up within certain questions, but generally want to focus on the use of the precedent rules more so than the factorisation and the use of indices. For reference, there is a separate presentation on factorisation and also the use of the laws and the rules of indices. And example 3a, again we're asked to simplify the following algebraic expression. We're given 2c minus 3, all divided by 4c, and we're adding to that 5 multiplied by 2 cubed, and we're adding to that 3 multiplied by c. If you want to add brackets around the numerator and denominator, that helps you clarify the problem, that's fine. So looking at our precedents in this question, well, we do have brackets effectively. We have a bracket on the top line here and a bracket on the bottom line here. But it can't be simplified because on the top line we've got 2c minus 3, so they're not like constants because c is a variable and the 3 here is a constant. And on the bottom line we've just got 4c. So there's no way we could simplify these terms even with the brackets around them. So my next precedent I can see will lie with the 2 cubed. That's an operation, so we will have to do that first. And then we have division here, multiplication here. Those will be the next precedent before we end up undertaking the addition, which will be here and here. That's my thinking steps, if you like, through the process applying the precedent rules. What I think I will do with this first term is write it into its partial fractions. So the 2c minus 3 upon 4c, the 4c is a common denominator there, so I could actually write that as 2c over 4c minus 3 over 4c. And again, if you refer back to our separate presentation on use of fractions, you'll see how we use these common denominators in that presentation. I've also got still my 5 multiplied by 2 cubed, but 2 cubed is 8, so I'll write that as 8, and I'm still adding 3c. Just for reference, the 2 cubed there is my 8 here. I'm simplifying on the next line. I can see that these two c's will effectively cancel, divide top and bottom by c. You get effectively 1 here and 1 here, and 2 divided by 4 is the same as a half, so dividing top and bottom by 2 I get a half. So it's half minus the 3 upon 4c, I'm adding to that. Now I've got 5 multiplied by 8, so that's 40. And I'm adding to that my 3c. There's not much simplification in this line because the only like terms I have is the half, it's a constant, and the positive 40 is a constant. This term here and this term here are not like terms because that's 3 upon 4c here and that's 3c upon 1 here. This term has a c in the denominator and this term has a c in the numerator, so I can't add them together. So any simplification I can see here is to add the 40 and a half together. So 40 and a half, or 40.5, minus 3 upon 4c, and then add to that 3c. And that's as good as it gets as far as I can see there. Exercise 1, we're asked to simplify the following questions. Now actually question 1 through to question 4 here are numerical calculations, so we'll end up with a pure number. They're quite complicated calculations, you have to apply the precedent rules very carefully. So be careful with question 3, you've got nested brackets here, you have brackets within brackets, so we need to apply BODMAS carefully within the brackets. The question 5 and onwards are all algebraic expressions, so we will not end up with a pure number, we'll end up with an expression with appropriate symbols. I would encourage you to start the presentation and attempt these questions. The answers are shown on the right hand side here in the square brackets. I will review some of these questions in exercise 1 on the following slide. So exercise 1 here, we have 61 added to, in brackets, 23 minus 15, which is all multiplied by 2. So again, applying BODMAS here, we need to deal with the bracket first of all, so that will be 61, we're adding to that 23, take away 15, that will be 8, and that's multiplied by 2. So the precedent was initially with the bracket, now the precedent is going to be with the multiplication. So that will now be 61 plus 8 times 2 is equal to 61 plus 16. So the answer is equal to 77. Question 2, I'm going to slightly rewrite this to a bit more clarity. 30 minus, in brackets, 17 plus 4. Again, I'll keep my bracket here. All divided by 3. Sometimes it's clear to understand the questions and what's required when it's written on 2 lines. So in this case, the precedent will lie with the bracket first of all. So let's simplify the bracket. So I'll end up with 30 minus 17 plus 4 is 21, and that's all divided by 3. Now my precedent lies with the division. So on the next line, 30 minus 21 divided by 3 is 7. And finally, undertaking the subtraction here, 30 minus 7 is 23. Question 3, we've got nested brackets here. We have brackets within brackets, so we have to focus on the brackets first of all. So these brackets shown here, I've just shown different types of brackets just for clarity here. Doesn't mean anything that I've got different symbols for my brackets. So I've got 3 plus 4 multiplied by 8 minus 3 in a bracket minus 6. That's all contained within my curly brackets as I've shown them here. So applying BODMAS within the curly brackets, I have a bracket here to deal with. So my precedent will lie here, then it will lie with the multiplication next, and then the addition and subtraction finally. So undertaking a calculation, we have 4 plus 2 multiplied by, curly bracket here, 3 plus 4, and the bracket there is 8 take away 3, so that's 4 multiplied by 5, and that's minus 6 inside my curly bracket. Considering BODMAS still within my curly brackets, the precedent lies here with the multiplication. So on my next line, I now have 4 plus 2 multiplied by 3 added to 20, and then minus 6. Next line, 4 plus 2, and evaluating the curly bracket here, 3 add 20 is 23, and we're subtracting 6 from there, so that becomes 17. The precedent now lies with the multiplication here. It's 2 multiplied by 17, So that's equal to 4 added to 34, 2 times 17, 34. And finally addition here, we will end up with 38. Exercise 1 part 4 here. I'll slightly rewrite this question. 3 multiplied by 5 plus 2 in the bracket, and we're subtracting from that 2 multiplied by the bracket of 3 plus 7, and that's all divided by 5. My precedent lies with the 5 plus 2 in the bracket and with the 3 plus 7 inside the bracket. From the next line we've got 3, that's multiplied by 7, so 7 here, and we're subtracting from that 2 multiplied by 10, 3 plus 7 is 10, and that's all divided by 5. The next line, my precedent lies with the multiplication in this first term and multiplication and division in the second term. So 3 multiplied by 7 is 21, we're subtracting from that 2 multiplied by 10 is 20, divided by 5 is 4. So my final answer is 21, take away 4, which gives us 17. So part 5 exercise 1 now starts looking at the algebraic terms. So we have 5a added to 5 multiplied by, in brackets, 2a minus 3a. So though this has algebraic symbols in it, we have the a symbol here, a variable, it doesn't make any difference to it, we apply our BODMAS. The precedence will lie here first of all with the bracket, and then here with the multiplication, and then the addition. So our calculation is 5a added to 5 multiplied by the bracket, we've got 2a minus 3a in the bracket, so it's actually a negative 1a, or just negative a inside the bracket. Our precedent now lies with the multiplication here. On the next line we have 5a, and 5 multiplied by negative 1 will be negative 5a. Now 5a subtract 5a is equal to 0. Exercise 1 part 6, then I'm going to rewrite this slightly. So y divided by, in brackets, 5y plus 2y minus 3y. That's the sum we're performing here. So our precedent lies with the denominator of the fraction here. So on the next line we will have y divided by 5y add 2y is 7y, and we're subtracting 3y. If it helps you, you can think of there being 1y in the numerator, with the fraction there. So on the next line what we're going to do is cancel the y's top and bottom. So this y cancel with this y, give us 1 top and bottom. So we end up with simply 1 upon 7 minus 3y. These are not like terms. The 1 upon 7 is a constant, and we've got a variable here of the y, so not like terms. So there's nothing more we can do with that sum, and that's as far as we can simplify it. Exercise 1, part 7, we're asked to simplify the following expression. 2b added to 5b multiplied by 3b, subtract b. We think of that as being a 1b, if that helps you. So considering the precedence, we have no brackets and no operations, but we do have a multiplication, so we have to deal with that first of all. So simplifying, 2b added to 5b multiplied by 3b is 15b squared. Don't forget that's b to the 1 and that's b to the 1 there. So applying the first law of indices, we end up with b squared. And we're still subtracting the 1b at the end. Now looking for like terms here, we have a 2b and a negative 1b. This b squared term is not a like term. So simplifying 2b subtract 1b, we end up with 1b, or simply b, added to 15b squared. There's nothing wrong with that format, that's absolutely fine, but I notice on the sheet they've actually factorised the final answer. So factorising on b, we take b outside the bracket, inside the bracket we'll get 1 added to 15b. Do not worry too much about the factorisation, there's a separate presentation on factorisation As long as you understand the solution simplified to b plus 15b squared, that's fine at the moment. Exercise 1 continued. Again, we're asked to simplify the following expressions. This is question 8 through to question 14. Again, I would encourage you to stop the presentation and attempt these questions. Answers again shown on the right hand side in square brackets. The solutions will be worked through though on the following slides. Exercise 1, part 8, we're asked to simplify the following expression of 2x multiplied by, in brackets, x plus 5x, and we're subtracting 3x. Looking at our precedence here, the precedence lies with the bracket. So simplifying, we'll have 2x multiplied by, inside the bracket, x plus 5x is 6x, and we're subtracting 3x. Precedent now lies with the multiplication here. So on the next line we will have 2x multiplied by 6x is 12x squared from our first law of indices, and we're subtracting 3x from that. That's fine, but again I can see we can factorise here. So the highest common factor is 3x. So we can take 3x outside of a bracket, and inside the bracket we will have 4x and negative 1. Again, at this stage, do not worry too much about the factorisation. If you're struggling with that, there is a separate presentation on factorisation. Exercise 1, part 9, we're asked to simplify x divided by, in the bracket, 5x plus 2x minus 3x. Just going to write on 2 lines, I think, to make it simpler to understand. So we've got x divided by, in brackets, 5x added to 2x subtract 3x. So the first thing we need to do is to simplify the bracket in the denominator, so we end up with x divided by 5x add 2x subtract 3x is 4x. If it helps, you can think of that as being 1x on the top line and 4x on the bottom. So the x's cancel, give us 1 and 1, so we simply end up with 1 upon 4. Part 10, we have 3a, add 2a multiplied by 4a. We're adding to that a divided by 5a, and we're subtracting 8a. Putting our precedence here, precedence lies with the 2a multiplied by the 4a and the a divided by the 5a. I'm just going to write this onto 2 lines. So 3a added to 2a multiplied by 4a added to a divided by 5a subtract 8a. So that's equal to 3a added to 2a multiplied by 4a is 8a squared. Now again, if you want to think of this as being a 1a upon 5a, the a's will cancel, so we end up with 1 upon 5, and we're subtracting 8a. Considering like terms here, the 3a and the negative 8a are like terms. This is not a like term, this is 8a squared, and this is a constant 1 upon 5. So simplifying, we could write this as 8a squared minus 5a added to 1 upon 5. And this is for the final solution. They factorise the first 2 terms on a. So they have a outside the bracket, and we have 8a minus 5 inside the bracket, and we have the constant at the end. Exercise 1, part 11. I'm just going to write this expression on 2 lines. So our first precedence here is with the bracket, then with the multiplication and division. So evaluating the bracket, 3z add 2z is 5z, which is multiplying by 4z. If it helps you, think of this being 1z upon 5z here, so the z's cancel to leave us with 1 upon 5, and we're subtracting 8z. Our precedence now lies with the multiplication. So on the next line we will have 5z multiplied by 4z, that's 20z squared, adding to that 1 upon 5 minus the 8z. The answer on the sheet stated is in factorised form. So what they've done is factorise this term and this term on 4z. So 4z outside the bracket, inside the bracket. To create this term we'll need 5z, and to create this term we'll need negative 2. We still have the constant of a fifth to add. Exercise 1, question 12. Again, I'm going to write this onto 2 lines. So evaluating our brackets on the top line, we have 3a add 2a, that becomes 5a, and that's multiplied by 4a add 1a, so that's 5a also. And we're dividing by, on the bottom line, 5a subtract 8a, that would be negative 3a. Thinking of the top and bottom in terms of brackets, if that helps. Evaluating the top line, we end up with 5a multiplied by 5a is 25a squared. That's all divided by the negative 3a. And then from the laws of indices, we can cancel the squared on the top with the a on the bottom. That's a to the power 1, of course, there. So that gives us 25a over negative 3. Just bringing now the negative to the top line, that's negative 25a, all divided by 3. Exercise 1, question 13. Again, I'm going to rewrite this onto 2 lines. So our precedent here lies with the bracket, although I cannot simplify the bracket because there's not like terms in the bracket, and then with the division and the multiplication. What I think I will do on the next line is actually write the first term in terms of partial fractions. So at the moment the common denominator for 2a and negative 3 is 4a. So I could write that now as 2a upon 4a, subtract from that 3 upon 4a. Add into that, 5 multiplied by 6 is 30, subtract 3a. I can now see that the a cancels top and bottom of the first term, and 2 upon 4 is the same as 1 upon 2. Dividing top and bottom of the fraction by 2, I get a half. That's minus the 3 upon 4a, added to the 30, and subtracting 3a. The only like terms I have are the half and the positive 30. So simplifying 30, add the half, that's 30 and a half, subtracting 3 upon 4a, subtracting 3a. The answer on the sheet is actually in terms of decimals, so they've actually written this as 30.5 minus 0.75, that's a 3 upon 4, divided by my a minus 3a. Exercise 1 part 14, we're asked to simplify a third of 3k and then add that to 4k multiplied by 3k minus k in the bracket. Don't forget, from our fraction work we looked at in the previous presentation, the use of the term of actually means multiplication. So I could write this expression as a third multiplied by 3k, add to 4k, and that's multiplied by, in the bracket, 3k minus k. If it helps you again, you can think of the 3k here being divided by 1. So on the next line, and notice simplification here, that this 3 and this 3 cancels to give 1 and 1. So multiplying the numerators, that's going to be k divided by, multiplying denominators, 1. Added to that, 4k multiplied by, in the brackets, 2k. Our precedent now lies with the 4k multiplied by 2k here. So on the next line we'll have simply k added to 8k squared. And finally the answer has been factorised again, factorised on k, so k is outside the bracket, inside we'll have 1 plus 8k. There's our final solution. I'm going to leave you with questions 1 to 10 shown here. These relate to algebraic simplifications. So questions 1 through to question 10. I would strongly encourage you to stop the presentation and attempt these 10 questions, noting that the answers are given in the table below. Here's the bibliography used to help generate the presentation. Some very good engineering textbooks here. I hope this has been of interest to you, and thank you for viewing.